So 2.2 stuff, I'll grade the quizzes, so if you're watching this video later, that's what's going on here different. There's 2 handouts in everybody's hand right now to help prep us for quizzes tomorrow. We'll look to do 2 quizzes tomorrow. So let's first talk metric prefixes. Metric prefixes are going to come up a little bit in the next reading or 2. I don't think it's in tonight's reading. I think it's a little ways away, but we're going to get back into our metric prefix memory. It's good for us as Americans to just be familiar with the metric system. If you had me for 7th grade, and I think more than half of you did, this is already in there somewhere. These should be a boost to your grade. Just put in some memory time. So here's our scheme. There's 10 metric prefixes that we're going to try to memorize. Tomorrow, I'll give you the prefix. I'll say deci, centa, milli, micro, whatever. The order will be scrambled, and what you'd have to do is the symbol and the meaning. So the symbols are for sure the easiest one to do. How are you able to come up with the symbols for most of them?
It's the first letter.
It's just the first letter. What do you have to be careful about with the letters, though?
Is it capitalized?
Capitalized or not. Most of them are not. Okay, so if you go small letter, first letter, most of the way down, you're in pretty good shape. The biggest numbers are the ones that use the capital letters. So giga is the biggest number. Go capital on that. Mega is the other biggest number. So go capital on that. I don't know why deca they didn't go capital D, but you know, I didn't make up the system, so DA is what they did for deca. You could also do DK, if you've seen that before, that's also correct. So either DA or DK for deca. And then why does the M's go weird? There's 3. So mega is the biggest one, so they go capital letter. Milli is the little m. Then micro, you have to go with a Greek letter mu, a Greek M. If you just draw a cursive U, that is a Greek M. Like, I just drew a cursive U, and then I'll just say, act like it's an M, and it is. Make sure you get those spokes down both sides, just like you do for a cursive U, but draw yourself a cursive U if you still remember cursive, and act like it's an M because it is. But that's our deal with the symbols. Question on symbols. Numbers, I'll give you some memory tricks. You could either listen to them, or you could jot them down, or you could ignore them. That's up to you. Anything D's or 10s. So what are some other D words that are 10s from your life history? Decades have 10 years. Dimes have 10 cents. I don't know, Spanish, what's 10? Probably starts with D. Okay, so I know French. French is D's. It's all 10. 10 stuff is 10 D's. So deci, deca, 10s. The ones that end in I's tend to be the fractions, and the ones that don't end in I's tend to not be fractions. So deci is the fraction of a tenth, deca is the tenth. Centa. How does centa remind you of 100? What other 100-based words might remind you of centa? Centuries, 100 years.
Cents.
Dollars and cents, 100 cents in a dollar. Think bugs. Centipedes. Anybody know Spanish? Hundreds, probably a C word. Is it? Yeah. Okay, so French, I know French, it's cent, C-E-N-T, is 100. The other 100 thing is hecto. Hecto, 100, H, just link that in your mind. You know, 100 starts with H, hecto starts with H, there's our hundreds. Thousands, what kind of stuff do you have with thousands that deal with like a milli reminder for thousand? Millipede, 1,000 legs. Millennium, 1,000 years. French number is mille, M-I-L-L-E in that language. Spanish, I bet it starts with something like that. Does anybody know Spanish? 1,000? I bet it looks like milli. They're all sharing the same things. Kilo for 1,000, I don't have a great trick other than K is a pretty common abbreviation for 1,000. If somebody tells you, like, for my salary, I'm making 30K, they're making $30,000. If you're into the world of computers, like kilobytes and stuff like that, that has to do with thousands. Mega, micro, million, those are all M's. So mega, micro, million, like those with M's in your mind. Mega obviously sounds big. You know, you get the mega box of Oreos, that's going to be a big box of Oreos. That's a lot. If you got a micro anything, that's little. So micro is the fraction, mega is the big. And then I don't have a real great trick for nano or giga, they just sort of are what they are. But tomorrow, that's a 20-point quiz. I'll give you the prefix, you give me the letter, you give me the number, 20 points, there we go. Tomorrow's Thursday. Friday's the hardest way, I think. I give you the letter, and you have to spell the prefix correctly, and that might take a little bit of practice, and also do the number. Weekend, Monday, come back, I'll give you the number, and you do the other two. And then when we get to Tuesday, it's just an empty paper where you just wrap them all off there. And there's 2 extra credits available when we finally get to the empty paper Tuesday. Anybody remember an extra one? You'll have to fill this in yourself. I didn't write the extra ones on. Anybody know something? Pico, P-I-C-O. That is going to be the symbol with a little p. And it's going to be a longer fraction than nano. Take nano's fraction and add on 3 more zeros. So instead of 9 zeros, there's going to be 12 zeros. If you don't like writing all those zeros, you can write that with an algebra trick of calling that 10 to the negative 12th. Negative powers are what make fractions, and then the 12 is your count of your zeros. So if you'd rather write 10 to the negative 12 on that, be my guest. For giga, you could write like 10 to the positive 9. If you don't want to write all those zeros. Positive powers are big boy numbers and negative powers are fraction numbers. Then there's one more extra one. Anybody in memory from 7th grade, days gone by? Femto, F-E-M, like monkey, F-E-M-T-O. Symbol, you could probably guess. Little f. And then add on 3 more zeros to your fraction. 1 on top of, have a 1 on the bottom, and then tack on 15 zeros. If you don't want to write that monstrous fraction, you could write that with powers as 10 to the negative 15. If you like that better, do that. That's fine. Question about metric, that'll be a series of 4 days again. Next day, I give the first column, then I give the middle column, then I give the third column, the 4th day I give you nothing, and on the nothing day, that's where you can do the extra credit. Pico Femto don't come out until extra credit day. Please don't say, is today the day we can do Pico and Femto? Because then I have to say, well, it would have been, but you just said them out loud, so no. And that has happened. And I've had people that are like, is today the day I can say Pico and Femto for extra credit? It's like, well, that's what I was hoping, but yeah, no, not now. But that's on empty day. Last call, metrics. Okay, vocab quiz. I gave you a sort of kind of copy of the vocab quiz, so let's look at the sort of kind of copy of the vocab quiz. Tomorrow you're reading 2-3. It's the shortest read of the year so far. I don't know about ever, but 2-3 is basically like a one-page-ish kind of thing. It only provides you with 1 new point. So number 1 you can see is a fill in the blank, 1 new question. I'll leave that up to you to find it. In terms of the rest of the quiz, it's built off of what we did today. So I will pick 6 properties and tell you names of them, and you'll do an algebra thing of them. So for rehearsal of that, I've got a board area ready here. I'm not saying these are the 6. I'm not saying these aren't the 6. I'm saying there will be 6 on the quiz tomorrow, and there's 1, 2, 3, 4, 5, 6. There's 7 on my board right now. So maybe it's these, maybe it isn't, I don't know. But could anybody, without study prep time, write an algebra sentence with like A's and B's and stuff for the addition property of equality? Okay, is that a hand?
Plus B equals B plus C.
That's the commutative property.
Okay.
Yeah, that's adding, but that's the commutative property.
Isn't it like if A equals B and C equals D, then A plus C equals B plus D?
That's correct. We need to set up some equals. If A equals B and C equals D, then we can add them up, 1 from each group. A plus C equals B plus D. That's the addition property of equality. The addition property of equality you've used in your life. The addition property of equality is what lets you solve this equation. So if we go back to 7th grade, the equation was like the scale. Whatever you do to one side, If you do the other, you always do the opposite, that scheme. Okay, but in 7th grade, you'd see a subtract 3, and you would know to add 3. You'd add 3 to this side, you'd add 3 to that side. These things were equal before. We added the same thing to both. They'd still have to be equal. That's what this is doing. We have equal things, we just add them together. That's the addition property of equality. And here's, I think, our first abbreviation of the year. I will never write out, not even one time, addition property of equality with my chalk on the board. I'll always just abbreviate that APE, 8, the addition property of equality. SPE is the subtraction property of equality. I'm just going to call that SPE because it's just easier than saying subtraction property of equality. Somebody other than Joseph, now that you saw the addition property happen, can somebody do the subtraction property of equality?
Is it still if A equals B?
Same beginning, so I'm just going to use ditto marks a lot this year to mean, like copy it, ditto, but it changes after the then.
A minus C equals A minus C
A
equals
minus.
B minus D.
Correct. We'd want to subtract one from each group. If A is subtracting C, B is subtracting D. So what do you think MPE is? Multiplication property of equality. It has the same beginning. Well, what do you think would be going on there?
Like AC equals BD.
AC equals BD for the win. DPE would be the dividing property of equality. That had a small detail because dividing is picky. There's something you're not allowed to do with dividing. Does anybody know what I'm after there?
It's I don't know, it's just one of them has to, like, can't be 0.
Correct. You're not allowed to divide by 0. So this is like, you have equal things, you have some third number not allowed to equal 0, then the A could divide C, the B could divide C. Dividing, you're not allowed to divide by 0. That's been a rule for a while. Transitive property. You've seen the transitive property before in the algebras. Does anybody remember the transitive property?
Is that A plus?
There's no add or subtract or anything like that in the transitive. Anybody remember transitive? That's correct. If A equals B, and B equals C, then A equals C. Our book did this, I think, with graders, which is fine. Or maybe our book did this with lessons. That's fine. People try to apply the transitive property to sports all the time. That doesn't really work out. Like, if the Steelers beat the Bengals and the Bengals beat the Browns, that doesn't necessarily mean the Steelers will beat the Browns. Like, maybe they will, maybe they won't. We're also maybe living in a fantasy land this year for the Steelers beating the Bengals. I don't know about our confidence level in that particular game right now, but we'll see how that works, I guess. Go Steelers, I'm with you, but that's dicey. But that's the transitive property. It works better for math than it does for sports, for sure. TRICH is trichotomy. That's an abbreviation for trichotomy. That's a new one. You never saw trichotomy before in your life, I don't think, until the reading. And if you didn't read the reading, you never saw it in your life until this moment. Anybody have a memory of what the trichotomy property was about?
For every x and y, only one of the following can be true. X is greater than y, x is equal to y, and x is less than.
That is correct. Anything with tri has to do with 3. So this is just telling you, in the world of math, you only have 3 options. This is telling you, for any x and y, only one can be true. Either x beats y, x loses to y, or x is equal to y. You can't have more than one of those at a time. You just pick one. X is more, x is less, or x is equal to y. That's just the way that is going to be. Here's answer to quiz question 8. So you've got this study paper, that 2, 3, 4, 5, 6, 7. Maybe I'm picking properties, maybe I'm picking others. Like, what other properties didn't I pick today? Because they're more familiar to you, so I didn't feel a real need to rehearse those. distributive property, commutative, associative. So if I pulled out associative, commutative, or distributive tomorrow, that would be fair. We didn't rehearse those today, but you've rehearsed those in Algebra 1, you've rehearsed those in Algebra 2. So I'm not saying don't know them, I'm not saying know them. I'm saying I'll pick 6 properties, maybe it's these, maybe it won't be these. But in my opinion, distributive, associative, commutative would be fair questions for me to ask, even though we didn't practice. 8, anybody have a thought on what the answer to 8 is about? How are the properties of inequality different from the properties of equality? Because as you read on in the reading, there was an addition property of inequality. I believe there was a subtraction property of inequality. If it wasn't in this section, it's coming. Yeah. That's exactly right. Yep. Inequalities have greater or less, whereas equalities have what? Equal signs. So if I go back up here and tell you something like if A is less than B, and C could be less than or equal to D, when we add those, we'd still have the one thing less than the other. That's no longer an equality property, that's an inequality property, because I brought graders and lessons into the table. I could have done it with graders as long as I was consistent. I could have done it with lessons. I just have to be consistent. One of these can get away even with an equal to if you want it to be. But that's what's up with 8. Inequality means greater or less. Equality means equals. I'm not going to do those properties. Okay, so I will commit to the 2 to 7 properties. It'll be either the ones on the board or something out of associative, commutative, distributive. I'm not going to dip into any of the other like sort of obscure properties from that reading. Today you filled in the blank with intersection. Tomorrow I'm going up one more level of difficulty on that. Yesterday we did a symbol. Today we filled in the blank with the word intersection. Tomorrow this goes in the other direction. Can anybody tell me what the intersection is?
2 sets combined.
That's the other one.
Everything in common between the 2 sets.
We're going to need the word in common, the phrase in common to be there. Not just the phrase in common, but that's like the center point of the issue. Full answer for 9 is that it is a set of elements common to both. The set of elements common to both. Remember, every definition starts with a category. So the category for this is that it's a set. The intersection itself is a set. It's a set of elements that are common to both. The union is a set of elements that are in one or both. So again, we talked yesterday about physics, we talked about geometry, and one of the answers was grant. That's it. Was that the intersection or the union? That's the intersection. We talked for the other answer, union, that would be like a group of 30 kids. It's everybody from this before lunch plus everybody in the after lunch. We put you together. We'd have class in the gym somewhere, I guess, because that's a humongous group of people. The union, to be in the union, you can be in one or in the other or in both. It doesn't matter. If you're in a group, you're in. Intersection, you have to be in common to both. 11, what's up with 11? It's an empty set, that's true. 12, the category we want to use for 12 is that it is a statement. 13 is also a statement. What's different about theorem versus postulate? They're statements. How do we contrast postulates versus theorem?
One needs proof and the other doesn't.
Which is which?
Theorem needs proof.
Correct. So 12 is a statement you have to prove. 13 is a statement. You can say statement accepted without proof. That's what I say. You could also say it's a statement that doesn't need proof, and I'm okay with that. You can rephrase those in your own words. You just have to reflect the right ideas. But 12, it's a statement you do have to prove. 13 is a statement you don't have to prove, or a statement accepted without any proof. What is a proof?
A logical or convincing argument.
Convincing logical argument. So proof, convincing logical argument. So you flat out have the answers to the bottom 7. We a little bit practice the type of thing we're doing from 2 to 7 is stuff like this. You might have to practice that a little bit more. one, you just have to read to figure out what's going on. Question about the vocab quiz? Yep.
What was that?
Which was which?
10.
10 is the set of elements that are in one or both. So if we did the union of this class with senior homeroom, you're in it because you're in both. Bella's in it because she's in senior homeroom. Melissa's in it because she's in this one. You can be in one or both, and it doesn't. If you're in anything, you make it into the union.
Are we taking 2 quizzes?
2 quizzes, yes. So we'll do the metric and we'll do this 2 quizzes tomorrow. Yeah. And I'm hoping the metric quizzes boost your grades. It should be easier to study the metrics where you know exactly what it all is. Then this has a little bit of mystery to it. I think there's a higher degree of difficulty. But usually the metric quizzes are a nice little beginning of the year grade, up, up, up. Especially if you hit that 36 out of 30. Like, I gave you 6 bonus points for Tuesday. There are some of you who haven't even missed 6 points yet. So you take the few points that you already missed and you wipe them out with extra credit points. You're like over 100% maybe some people. Like other people, you have missed more than 6, but it's still nice to get 6 bonus points for Tuesday and found out some metric stuff. Yeah.
May I go to the back?
Short. Question about quiz lives. Okay, let's look at homework preview page. I'll give you a little bit of a starter on the homework tonight. Tonight we're working page 25. So page 25, we're working a 1 to 10. 1, I don't think you're going to need help. It's just filling in greater, less, or equals. So that's a deal on 1. 2 and 3, they want you to figure out what property it is. Let's give 1 away for free, just for the heck of it. So 2 anywhere, 3 anywhere. Can anybody recognize any property on page 25, number 2, number 3, anything there that you know which property it is? Some of the ones that are on the board are there, some of the ones on the board are not there. Let me do this. I'll narrow it down. Let's do 2C. Can anybody tell me what's happening on 2C? It is the addition property of inequality. How do you know it's an addition property? They got added together. They had 5s, they had 2s, and all of a sudden they're 7s. They had 9, they had 3, all of a sudden they have 12s. You'd have to just try to process that and come up with the idea, hey, these guys are adding, it's an adding property. And then if you were listening in when Emma talked, the inequality properties had the lesses. The equality properties had equals. That's one that had lesses, so that's for 2C, the addition property of inequality. Anybody 2, 3 not get the point of what you're trying to accomplish? 4, I don't think you need me to do a number line and mark numbers off there. What you want to do though is do the square roots as you go. Like the square root of 9 is better known as 3. So I don't care on your number line if you mark it as root of 9 or if you mark it as 3. I'd consider those the same, so I don't care. 5, try to fill in the blank with greater or less, one of those symbols. I don't feel like doing that right now. 6, I don't feel like doing right now. Let's talk about 7. We haven't talked about the numbers at all today. You read about the numbers, you did a matching on the numbers. Can somebody for 7 explain to me real numbers? It's every single number. So every single number in this list is a real number. It's all the numbers you know. Other than if you've had Algebra 2, you ventured temporarily into some imaginary numbers, i's and stuff. If you haven't had Algebra 2, stay buckled in for that. This book does not acknowledge imaginary numbers, so you don't have to worry about it. Real numbers for now are still all the numbers you know. Rationals versus irrationals. What's the difference for rationals versus irrationals? Can be fractions and irrational can't. Are there more rationals in this list or are there more irrationals in this list?
Irrational?
Disagree. There's not a lot of irrationals. There's some, but it's not frequent that you have something you can't write it as a fraction. Like if I say to you 10, 10 is rational. Why is 10 rational? 10 over 1. If I give you a decimal, that's usually rational, because you can usually turn decimals into fractions. The most famous irrational number is in this list. Who's the most famous irrational number?
Pi.
Pi. Pi is irrational. What other kinds of numbers on this list are irrational? Roots of things. Okay, are all roots irrational? No. Somebody give me a root that's rational. Root of 4, because root of 4 is better known as
2.
2. That's rational. But if I do like the root of 5, you can't do the square root of 5 and get like a set rational answer. The square root of 5 is a decimal that just never ends or repeats. Integers. What are our integers? Yeah, not just on there, but like in life, what are the integers about? Where in my room can I point you to integers?
Number line.
Number line. Everything I marked on the number line is an integer, whether it's negative, whether it's positive, whether it's 0. Every number line marked number, that is an integer. It doesn't include stuff like 2.5. 2.5 is not an integer. It has to be the slots that I marked. Those are the integer slots. I don't care if you do this, they say make a table. I don't care if you make a table or if you make a list or how you do it, but you're trying to categorize what categories they go in. Are most of the numbers only in one category, or most of the numbers actually in lots of categories? Most of them are in lots of categories. There's quite a few that are, well, everything's real. Then you have to be either rational or irrational. Pick one. You can't do both. And then the integers repeat some of those categories as well. So that's what 7 is doing. And then true, false till the end. I'll just leave you there, I think. Does anybody have something on 25 that you feel like you need a little more advice or preview to be comfortable with the strategy of what you're being asked to do with it? Anything there? 25 trouble? If you can, fish out your 18. We still have like 2 minutes. Does anybody have a 2-minute or less question for 18 before we turn it into something that you were like, I don't know what I was supposed to do with 18? Someday we'll go through the homework in detail. Do you have something that was weird?
Yeah, for the final, for the last one, what were we supposed to do there?
You're trying to come up with a count of subsets. Like, they did an example where if they start you with A and B, and you want subsets, taking a both is a choice, taking just A, taking just B, or taking the empty set, this set can create 4 subsets. Then they ask you to take it up a notch, and to do that, if you started with 3 letters, list every subset you could do. Groups of 3, groups of 2, groups of 1, group of empty. Then they wanted you to consider if they had a 4th element. Groups of 4, groups of 3, groups of 2, groups of 1. They just want you to count how many you can make. On the 3 group thing, they actually wanted you to make the list. On the 4 group and the 5 group, they're just asking you, like, how many do you think there are? You don't necessarily have to list them all if you found a pattern to it. Anybody else 18, anything that you were working and just thought, I don't understand what I'm supposed to do with this? We've got half a minute-ish. Make sure names are on there, label that as a page 18. Even if it isn't perfect, just send it down so I can see that you're working with it and trying. I'm thinking Friday's a day that all we do Friday is just like homework, iron out the kinks and homework for a day. We'd probably take the metric quiz and then there's probably nothing really else going on.